I wanted to take some time today and I wanted to go over your quiz from today with you. So let's just start at the beginning. It had said question 1 had asked you to figure out the actual and total states for each of the compounds, ions, molecules, or atoms listed. So let's just go ahead and jump right in. H2O, so actual state and total state. So let's talk about what we've got. We've got hydrogen and we've got oxygen, right? We know for certain oxygen is always -2. There's only one oxygen, so its total state is also -2. Hydrogen is generally always +1. Notice there's 2 of them for a total state of +2. Now that should make sense, +2 and -2, because the net charge on this compound is what? It is 0, right? We have a neutral compound, a net charge of 0, so +2 and -2 would give us 0. All right, B, O2. O2 is really just a free element, right? It's oxygen. Oxygen, when by itself, is diatomic, and anything that's a free element is going to have an actual state of 0 and a total state of 0. All right, permanganate. Permanganate is really just MnO4 with a negative charge, so let's talk about our actual and total. We've got manganese, we've got oxygen. Anything that we know for certain is oxygen, -2. There's 4 of them, so that's a total of -8, which means what? Well, manganese, notice there's a net -1 charge, right? So whatever this value is, it's got to give us a charge of net -1, which means it's +7. So there's only one manganese with a +7 charge. All right, D says ClO negative, hypochlorite. All right, so actual and total, what do we have? We've got chlorine and oxygen. Oxygen's always -2, only one of them, so -2. Notice we've got a net charge of -1, so whatever these are, they've got to give us -1, which means chlorine is +1. Only one of them that's +1. All right, sulfide, S -2. Notice it's an ion, right? Just an ion by itself. So actual, there's only one of them, -2, total -2. Fe, iron, is a free element, right? Notice no charge on it by itself, which means actual is 0, total is 0. All right, next question. What volume in milliliters of 6 molar nitric acid is required to react with 14 grams of magnesium ribbon? It tells you the molar mass of magnesium is 24.31. It's 24.31 or 30. Either one would have been okay, depending on the periodic table you were using. And it says you will need to write a balanced redox reaction for this before you can solve, and that HNO3 is an acid. Now, the only reason that's important is because if you were to do the whole process of redox, right? So if we picture it, if we've got magnesium, which is a solid, nitric acid, which is HNO3, reacts. It's really just a single replacement, right? So we're going to end up with magnesium nitrate and hydrogen gas. So in terms of breaking it apart, if we wanted to picture redox-wise, make sure it's balanced, we'll put a 2 there. Really, we've got 2H plus 2NO3 minus, yielding Mg parentheses NO32 plus H2. Sorry, let's go ahead and dissociate that as well, because that is aqueous. And it really just shows us that the nitrate is not actually a part of the reaction, right? Now, we could technically write the 2 half reactions in from this, which gives us 2H plus yielding H2, and it gives us Mg yielding Mg plus 2. And when we do that, you should hopefully probably notice that the electrons are equal, right? Notice that the amount of electrons that are going in hydrogen to make it go from +2 to 0 is equivalent to the amount of electrons going out in magnesium, which means we really don't even have to do anything because of our electrons are already going to cancel. So really our reaction is already balanced. Everything about this is technically already a balanced chemical equation. So we could really just do the math. So let's go ahead and do the math. In order to do that, I'm going to go ahead and move to a black screen so that you can see it more clearly. Alright, so let's just get started. Remember we said that we had our 2HNO3 plus our magnesium yielding magnesium nitrate plus H2. We also were told that we had 14 grams of magnesium. We were told the molarity of our nitric acid was 6 molar. And the question is, what is the volume in milliliters that we're going to use? Now, I remember this is really just stoichiometry, right? So we really are just trying to go from a known into an unknown. So let's just start with, maybe you hopefully noticed that if we just tried to go into volume with the nitric acid, we couldn't do it because the only thing we know right now for nitric acid is its molarity. We do not know moles. We also do not know volume. However, since we know the grams of magnesium, we could convert that to moles of nitric acid, right? It's really just stoichiometry. So that's what we'll do first. Let's go ahead and take that 14 grams. Let's get it into moles of magnesium and then into moles of nitric acid. So your setup should have looked something like this. Notice our grams of magnesium cancel, moles, we're left with moles of nitric acid, and that would give us 1.15 moles of HNO3. Alright, so now it's a matter of plugging into our equation. Now we know moles, so we've got 6 molar nitric acid. We know that there's 1.15 moles of that. The question is volume, but remember, since this is molarity, that's going to be us solving for liters. So let's isolate our variable, right? We don't know liters, but we could take 1.15 moles divided by our 6 molarity, which is just moles per liter, and we would end up with 0.192 liters of nitric acid. That's great. We're almost done. We're not done yet, though, because the question asked for it in milliliters. So now it's just a matter of converting it to milliliters, 1,000 milliliter in a liter. So really we have 192 milliliters of nitric acid, and we're done. That's it. If you should have any questions about that, please don't hesitate to ask. Otherwise, that's really all that you would need to do for that problem. Please make sure that you study for your exam. And again, contact me if you should need anything. I hope you have a great night. Thanks. Bye.